Hello everyone, let's talk about inverses. So we've graphed exponentials, we've graphed logarithms, we've talked about how if you flip the x and the y, the input and the output, you're using the inverse function. So we're going to do that now. We're going to take this exponential and we're going to find the inverse by flipping x and y. So instead of y, we're going to say x, and now this says 6 to the y. Now, the trick to this is you're trying to solve for y, and this is why we have logarithms. If y is in the exponent, then the way we get it out is we rewrite this as a logarithm. So if it's a base 6 exponent, we're going to write it as a base 6 logarithm. And remember, it's 6 to the y. The base 6 log of x is y. So you kind of have to see these two statements in the same way. These are saying the same thing, but if you want to get y by itself, this is how you do it. So these are inverses of each other. Well, these are the same statement, but one's a log and one's an exponential. Okay? That's the goal. Get y by itself. So now, we'll do the same thing. This is the output, so we'll just call that x e to the y minus 4. And now, we're going to rewrite this as a logarithm. And if it's a base e logarithm, we say the natural log. So that's like your e is down here. E to the y minus 4 equals x over here. E to the y minus 4. Okay, and that's x. Now, if I want to get y by itself, I will add 4 to both sides. So y equals the natural log of x. And I'm going to put that in parentheses, plus 4. The reason I'm doing that is I don't want it to look like this. Those are different. Remember, this one would shift up and this one would shift left. So I'm just going to be careful and put parentheses there. So y equals the natural log of x plus 4. Let's try a couple like that. X equals 3 to the y plus 2 minus 1. So before I can rewrite this, I need to isolate the exponent. So I'm going to add 1. X plus 1 equals 3 to the y plus 2. And now I will write it as a log. If it's a base 3 exponent, you write it as a base 3 log. 3 to the y plus 2. And then x plus 1 is the argument of the log. Last thing I want to do is subtract 2. So the log base 3 of x plus 1, and then I'll put minus 2 on the end, equals y. One more like that. X equals 2 to the y plus 8. Before you rewrite it, move the 8 over. And now, to get the y out, we're going to rewrite this as a logarithm. It's a base 2 log. So 2 to the y equals x minus 8. So when you write that as a logarithm, it's the base 2 log of x minus 8 equals y. So those are inverses of each other. You have an exponential and you have a logarithm. Now, going the other way, kind of feels more like what we're used to. But remember, if you see natural log, that's base e. So e to the y equals x plus 3. But I'm going to flip x and y. So maybe I should just do that first. X equals the natural log of y plus 3. And I'll write it like this. E to the x equals y plus 3. I could have just flipped them in the second step, but this is fine too. Okay. So e to the x equals y plus 3. And then to get y by itself, subtract 3 on both sides. So e to the x minus 3 equals y. Let's try another one. X equals the base 8 log of y minus 2. So flip the input and the output. Now, I want to add 2. X plus 2 is the base 8 log of y. And now I can rewrite it as an exponent. 8 to the x plus 2 equals y. Now let's practice that. X equals the base 5 log of y. Flip x and y. Rewrite it as an exponent. 5 to the x equals y. And that one you're done. X equals the base 6 log of y plus 2. So flip x and y. Rewrite it as an exponent. 6 to the x equals y plus 2. And now isolate y. And to isolate y, you got to subtract 2. So 6 to the x minus 2 equals y. There you go. We'll talk about the graphing implications of inverses later, but right now, I just want you to go through some practice problems and make sure you smash that like and subscribe.